Okay, good afternoon guys. Last session alli solutions complete ಮಾಡಿದ್ದೆ. ಈ ಸೆಷನ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರೋಕೆಮಿಸ್ಟ್ರಿ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡುವ. ಸೊ ಎಲೆಕ್ಟ್ರೋಕೆಮಿಸ್ಟ್ರಿ ಸ್ವಲ್ಪ ಇಂಪಾರ್ಟೆಂಟ್ ಚಾಪ್ಟರ್ ನಿಮಗೆ. ಸೊ 1 ಮಾರ್ಕಿಂದ ಒಂದು ಕ್ವಶನ್ ಇದೆ, 2 ಮಾರ್ಕಿಂದ ಒಂದು ಕ್ವಶನ್ ಇದೆ, 5 ಮಾರ್ಕಿಂದ ಒಂದು ಕ್ವಶನ್ ಬರುತ್ತೆ. ಸೊ 1 + 2 + 5. ನಾವು ಅಗೇನ್ ಶಾರ್ಟ್ ಪೀರಿಯಡಲ್ಲಿ ಯಾವುದನ್ನು ಕವರ್ ಮಾಡಬೇಕು, ಯಾವುದನ್ನು ಜಾಸ್ತಿ ಓದಬೇಕು, ಜಸ್ಟ್ ಸಮ್ ಡೆಫಿನೇಷನ್ಸ್ ಕೆಲವೊಂದು ಪಾಯಿಂಟ್ಸ್ ಮಾತ್ರ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ. So in that first one, let me explain about Korlach's law of independent mobility or migration of ions. Just Korlach's law istadre saku. Korlach's law states that nothing but statement enu molar conductance of an electrolyte at infinite dilute solution is the sum of contribution of cation and anions of the electrolyte. Molar conductance of electrolyte is the sum of contribution of cation and anion. ಇಷ್ಟು ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ ಸಾಕು. cation plus anion sum ಏನಿದೆ, nothing but molar conductance of electrolyte. Molar conductance of electrolyte at infinite dilute solution is this one, and it is the sum of contribution of cation and contribution of anion. So this is cation and this one is anion. So this is simple Korlach's law of independent migrations. So where lambda plus is cation and minus are anion respectively, then they are also called as ionic conductance because it is a conductance of cation and it is conductance of anion. So here I have taken 3 simple examples. For BaCl2, if I take any BaCl2, we know that BaCl2 undergoes dissociation or ionization in order to form Ba2 plus 2Cl minus. Therefore, according to Korlach's law, molar conductance of BaCl2 at infinite dilute solution is the sum of conductance by barium 2+ ion and conductance by Cl, but 2 ನೆನಪಿರಲಿ, reaction balanced ಆಗಿರಬೇಕು. So for AlCl3, it is Al3 plus 3Cl minus. For Al2SO4 thrice, it is 2Al3 plus and 3SO42 minus. This is Korlach's law. So next important definition andre, what are primary batteries, give example, and what are secondary batteries, give example. Primary battery is nothing but the battery which cannot be recharged are called as primary batteries. So ಯಾವ ಬ್ಯಾಟ್ರಿನ ನಾವು ರೀಚಾರ್ಜ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ, ಒನ್ ಟೈಮ್ ಯೂಸ್ ಮಾಡಿ ಥ್ರೋ ಮಾಡಬೇಕು, such type of batteries we call it as primary batteries. ರೀಚಾರ್ಜ್ ಮಾಡಿ ಮತ್ತೆ ಯೂಸ್ ಮಾಡ್ತೀನಿ ಅನ್ನೋದಾದರೆ then we call it as secondary batteries. The cell in which can be recharged by passing current through it in the opposite direction so that it can be reused. Simple agi, the batteries which cannot be recharged are called primary batteries. The batteries which can be reused are called as secondary batteries. Example for primary battery, dry cell, mercury cell. So simple small shell watch ಮತ್ತೆ ಗಡಿಯಾರದಲ್ಲಿ ಹಾಕುವಂಥದ್ದು. So secondary cell, you can give example of nickel cadmium battery. So motor vehicles all use motor batteries are examples of secondary batteries. And next definition, again most important one for 2 mark, Faradays First Law. Then Faradays First Law states that during electrolysis, the mass of the substance discharged, sometimes ಏನು ಮಾಡ್ತಾರೆ, ಇದನ್ನು ಡಿಸ್ಚಾರ್ಜ್ ಬದಲು ಡೆಪಾಸಿಟೆಡ್ ಅಂತ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಸೊ ಮಾಸ್ ಆಫ್ ದ ಸಬ್ಸ್ಟೆನ್ಸ್ ಡೆಪಾಸಿಟೆಡ್ ಅಟ್ ಅನ್ ಎಲೆಕ್ಟ್ರೋಡ್, ಕ್ಯಾಥೋಡಲ್ ಡೆಪಾಸಿಟ್ ಆಗುತ್ತೆ, ಈಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಕ್ವಾಂಟಿಟಿ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಪಾಸ್ಡ್. ಸ್ಟೇಟ್ ಆ್ಯಂಡ್ ರೈಟ್ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ಫ್ಯಾರಡೇಸ್ ಫಸ್ಟ್ ಲಾ ಅಂತ ಕೇಳ್ತಾರೆ. ಫ್ಯಾರಡೇಸ್ ಫಸ್ಟ್ ಲಾ ಸ್ಟೇಟ್ಸ್ ದಟ್ ಡ್ಯೂರಿಂಗ್ ಎಲೆಕ್ಟ್ರೋಲಿಸಿಸ್ the mass of the substance deposited is directly proportional to quantity of the electricity passed. Therefore, mathematically W proportional to Q, where W is mass of the substance discharged, where Q is the quantity of electricity passed. So proportionality remove ಮಾಡೋದಕ್ಕೆ introduce ಮಾಡ್ತೀನಿ Z introduce ಮಾಡ್ತೀನಿ, where Z is a proportionality constant called electrochemical equivalent. But we know that Q is equals to I into T, where I is current in ampere, where T time in second. Therefore, an expression for Faraday's first law is given by W is equals to Z into I into T are just W proportional to Q. This is Faraday's first law. Faraday's first law states that during electrolysis, the mass of the substance discharged at an electrode is directly proportional to the quantity of electricity passed. Next, Faraday's second law. So, Faraday's second law states that, so again similar, when the same amount of electricity is passed, when the same amount of electric current is passed through different electrolytes, here different electrolyte ಇದೆ, same amount of electric current na pass ಮಾಡ್ತಾ ಇದ್ದೀನಿ, then the masses of the substance discharged at the electrode are directly proportional to their equivalent masses. According to Faraday's first law, during electrolysis, the mass of the substance discharged is directly proportional to the quantity of electric current passed. ನಾನು ಅಲ್ಲಿ ಒಂದು ಎಲೆಕ್ಟ್ರೋಲಿಸಿಸ್ ಅಥವಾ ಒಂದು ಎಲೆಕ್ಟ್ರೋಡ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೆ ಅಥವಾ ಒಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೆ. ವೆನ್ ಒನ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ಈಸ್ ಯೂಸ್ಡ್, ಎಷ್ಟು ಡೆಪಾಸಿಟ್ ಆಗುತ್ತೆ ಅನ್ನೋದು ಕ್ವಾಂಟಿಟಿ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಪಾಸ್ ಮಾಡೋದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಬಟ್ ಇಫ್ ಯು ಯೂಸ್ ಡಿಫ್ರೆಂಟ್, ಸೊ ಡಿಫ್ರೆಂಟ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ಸ್ ಯೂಸ್ ಮಾಡಿದಾಗ, so between two different electrolytes, for example, you take this one as 1 and this one as 2. Okay, when two different electrolytes are used, okay, so when two different electrolytes are used in two different electrolytic cell, when the same amount of electric current is passed, through different electrolytes, mass of the substance deposited is directly proportional to their equivalent masses, and that is given by W proportional to E, where W is mass of the substance deposited, where E is equivalent mass. So, since we have defined it as mass of Y formed is proportional to equivalent mass of Y, and mass of X is proportional to equivalent mass of X. Mass proportional to equivalent mass, mass proportional to equivalent mass. Therefore, we can take it as mass of X by mass of Y is equals to equivalent mass of X by equivalent mass of Y. Same thing, namge M1 divided by M2, which is equal to E1 divided by E2 antanu ತಗೊಂತೀನಿ, where M1 is nothing but mass of one substance, M2 mass of second substance, E1 is the equivalent weight of first substance, and E2 is the equivalent weight of second substance. Clear? This is Faraday's second law. Next, one important 3-mark question or 2-mark ಕೇಳಬಹುದು, that is standard hydrogen electrode, SHE. So, then what is standard hydrogen electrode? Hydrogen gas at 1 bar pressure is in equilibrium with 1 molar HCl solution in presence of platinum electrode is called as standard hydrogen electrode. Complete definition of simple cell representation alli ಹೇಳ್ತಾ ಇದ್ದೀನಿ. Platinum electrode ಇದೆ, which is present in 1 bar hydrogen gas and which is in contact with 1 molar HCl solution. Then what is standard hydrogen electrode? An electrode in which hydrogen gas is at 1 bar pressure and is in equilibrium with 1 molar HCl solution in platinum electrode is nothing but standard hydrogen electrode. So, off cell reaction ನೋಡ್ಕೊಳ್ಳಿ. So, ಇಲ್ಲಿ ಏನು ಕೇಳ್ತಾರೆ, explain construction and working of standard hydrogen electrode, or write off cell reaction, cell representation of standard hydrogen electrode, or draw a neat label diagram of standard hydrogen electrode. So, this is standard hydrogen electrode. So, you will note finely divided platinum ಇದೆ. So, here you can observe. So, inner glass tube ಇದೆ, hydrogen gas pass ಆಗ್ತಾ ಇದೆ. So, ಇಲ್ಲಿ 1 molar HCl solution ಇದೆ. So, this is simple diagram which represents standard hydrogen electrode. So, standard hydrogen electrode is nothing but hydrogen gas 1 bar pressure is in equilibrium with 1 molar HCl solution in presence of platinum electrode at a 298 Kelvin is called as standard hydrogen electrode. ಇದ್ರ ಜೊತೆಗೆ ನೀವು H2O2 fuel cell ಬಗ್ಗೆ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿ. H2O2 ಫ್ಯೂಯಲ್ ಸೆಲ್ ನೀವೇನಾದರೂ ಓದ್ಕೊಳ್ಳಿ. ಸೊ ಇದನ್ನು ಕೇಳೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ ಬಿಟ್ವೀನ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಹೈಡ್ರೋಜನ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಆಸ್ ವೆಲ್ ಆಸ್ H2O2 ಫ್ಯೂಯಲ್ ಸೆಲ್. ನೆಕ್ಸ್ಟ್, ದೀಸ್ ಆರ್ ಸಮ್ ಆಫ್ ದ ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ಮುಲಾಸ್. ಸೊ ಈ 4 ಫಾರ್ಮುಲಾದಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದ್ರ ಮೇಲೆ ನಿಮಗೆ 3 ಮಾರ್ಕ್ ಕ್ವಶನ್ ಕಂಪಲ್ಸರಿ ಇರುತ್ತೆ. E is equals to E naught, EMF which is equals to standard EMF, nothing but E naught is equals to E is equals to E naught minus 2.303 R temperature, N number of change in electrons, F Faraday's constant into log of 1 divided by Mn plus. So oxidation state refer ಮಾಡುತ್ತೆ at a 25 degree Celsius. ಸೊ ಅಟ್ 25 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ನಾನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ 25 ಡಿಗ್ರಿನಲ್ಲಿ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಟಿ ಆಸ್ ವೆಲ್ ಆಸ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎಫ್ ಆ್ಯಂಡ್ ಆರ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀನಿ. ದೆನ್ ದ ಸೇಮ್ ಫಾರ್ಮುಲಾ ವಿಲ್ ಬಿಕಮ್ ಇ ಸೆಲ್ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು potential of cell is equals to standard potential E naught of cell minus 0.059 by 2 into log of. So instead of this one I have taken Daniell cell. So Daniell cell ತಗೊಂಡು Zn2 plus divided by Cu2 plus ತಗೊಂತೀನಿ. So this is another formula. Or you can use E naught of cell is equals to 2.303 into RT by NF into log Kc equilibrium constant ಮತ್ತೆ E naught ಗೆ relationship. And last one, delta G naught is equals to minus NF E naught. So potential ಮತ್ತು standard free energy relation, delta G naught is equals to minus NF E naught. So either EMF or delta G ಯಾವುದಾದ್ರೂ ಒಂದು 3 ಮಾರ್ಕ್ ಪ್ರಾಬ್ಲಮ್ ಬರುತ್ತೆ. ಅಟ್ಲೀಸ್ಟ್ ಯು ಟ್ರೈ ಟು ರೈಟ್ ಫಾರ್ಮುಲಾ 1 ಮಾರ್ಕ್ ಆದರೂ ಬರುತ್ತೆ. ಸೊ ದಿಸ್ ಈಸ್ ಅಬೌಟ್ electrochemistry, simple definitions. So in electrochemistry we discussed and we started discussion with Corlach's law of migration. So Corlach's law, molar conductance of an electrolyte at infinite dilute solution is the sum of contribution of cations and anions. So Corlach's law ಆದಮೇಲೆ ನಾವು Faraday's first law ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀನಿ. According to Faraday's first law, the mass of the substance discharged is directly proportional to the quantity of electricity passed. After Faraday's first law, Faraday's second law. According to Faraday's second law, when same amount of electric current is passed through different electrolytes, then the mass of the substance discharged at electrode is directly proportional to their equivalent mass. So next one is standard hydrogen electrode, platinum electrode, 1 bar hydrogen gas pressure and 1 molar hydrochloric acid solution is nothing but standard hydrogen electrode. So H2O2 fuel cell practice ಮಾಡಿ, then some of the important formulas for the problems. So question part D ನಲ್ಲಿ electrochemistry ಇಂದ ಒಂದು 5 ಮಾರ್ಕ್ ಪ್ರಾಬ್ಲಮ್ ಕ್ವಶನ್ ನಲ್ಲಿ 3 ಮಾರ್ಕ್ ಪ್ರಾಬ್ಲಮ್ ಬರುತ್ತೆ. ಸೊ 3 ಮಾರ್ಕ್ ಪ್ರಾಬ್ಲಮ್ ನಾನು ಹೇಳಿದ್ದೀನಿ either EMF or delta G ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮೇಲೆ ಇರುತ್ತೆ. ಸೊ ಈ 4 ಫಾರ್ಮುಲಾದಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದು ಫಾರ್ಮುಲಾ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ ಬರುತ್ತೆ. ಸೊ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ, ಪ್ರಾಬ್ಲಮ್ಸ್ನ ಸಾಲ್ವ್ ಮಾಡಿ. ಸೊ ದಿಸ್ ಈಸ್ ಅಬೌಟ್ ಎಲೆಕ್ಟ್ರೋಕೆಮಿಸ್ಟ್ರಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ಸೆಷನಲ್ಲಿ ಇನ್ನೊಂದು ಚಾಪ್ಟರ್ ಜೊತೆ ಡಿಸ್ಕಸ್ ಮಾಡುವ. ಸೊ ಟಿಲ್ ದೆನ್ ಟೇಕ್ ಕೇರ್, ಸ್ಟಡಿ ವೆಲ್.